Okay, this week we are starting on the scientific method. The scientific method obviously has to do with experiments. We will be doing an experiment in class. And you need to know that when we do this experiment, it is not just a class thing. Because see, I'm a very competitive person.
Oh yeah.
Me too. And so is Mr. Beckham down at the other end of the hallway. And Mr. Beckham and I, we kind of compete against each other in things. Because, well, honestly, he thinks he's better than me, but he's not.
No.
So, we are going to be competing against Mr. Beckham's class on how well we do on experiments. And each time we do an experiment like this, we're going to be competing against his class. Because, honestly, so, to be able to do experiments though, and to know whether an experiment is a good experiment or not, we have to know what our variables are and what they mean. And so that's what we're going to be doing today and tomorrow. And that's why I emailed you this. There are 3 different types of variables. There's an independent variable, a dependent variable, and then control variables or a whole control group. So the first thing that we're going to go over is dependent variables. Dependent variables. Every experiment always has a dependent variable. Your dependent variable is dependent. You are dependent on your dependent variable because you have to do a graph, right? Every experiment always has a graph. Your graph is based on numbers. Your numbers are based on what you measured. What you measured is your dependent variable. Your dependent variable is what you measure in your experiment. Now, you say, well, I can measure an experiment, but it's off of words like little and a lot. How are you going to graph those words? Can you graph words like a little and a lot?
Yeah.
Can you go into Excel and type in a number for a little? No. What's a little to you may be totally different than what a little is to me. For example, you may say, I need a little bit of salt on your food. And I may say, I also need a little bit of salt on my food. So then I give you the salt shaker and you just kind of tap it so that you get a little tiny, tap, tap, tap. Well, a little salt to me is like 5 heart shakes. So that could be the difference between 1 teaspoon of salt and 1/8 of a teaspoon of salt. There's a big difference there. Maria.
Like how if compared to $40, it's not a big deal to them, but when we have it, we feel like we're rich.
Yes. So it's a lot to you, but it's a little to them. Okay? $20 is always a lot to me, but that's the point. Anyway, so that's why our dependent variable, we always have to have numbers. We always have to measure in numbers. You may measure distance. How far did the paper airplane go on the first trial? How far did it go on the second trial? So we're going to be measuring in feet, or in meters, or in yards. Or you could measure time. How many minutes did it take for the ice to melt that was on the black construction paper? Or you can measure days. How many days did it take for the mold to grow on the wheat bread? Or you could measure liquid amounts. How many ounces of pop was left in the pop can after exploding? How many ounces or liters of pop was left in the bottle after the explosion? We have to have numbers though. If you don't have numbers, you can't graph it. Okay? Okay. So that's what your dependent variable is. Your dependent variable is a thing that you measure in your experiment. Go to the next one. Independent variable. Now, how many people have ever heard of these words before? Independent variable and dependent variable. How many people have never heard these words before? Oh, holy cow. Okay. Independent starts with what letter? I. And the variable starts with what letter? I, V. What is the first thing that pops in your head when you hear IV? Jimmy.
The medicine that they pump into your arm.
The medicine that they put in your arm. That's actually not the medicine, but it's the needle that goes in your arm. It's the IV. What else do you think of?
Like the numbers, how it's
Roman numerals. IV would be a 4. Rocco.
Like poison ivy.
Like a plant. Poison ivy. Or you have the ivy plant. What else?
the word
Ive. You have your contraction, Ive. You add an E. Or someone said Hy-Vee. I think of the grocery store Hy-Vee when I hear the word IV. That's fine too. What I think of is I think of hospitals. Because like Jimmy said, an IV is something, a needle, that they put in your arm that goes into your vein. Why do you have an IV if you're in a hospital? Are you healthy?
No.
Probably not. Something's wrong, right? And you need to get better,
They had to do that to me.
right? Sometimes you have an IV to give you fluids because you're dehydrated. You haven't drank enough water. Sometimes they give you an IV and they give you blood for a blood transfusion because you need more blood in your system. Sometimes they give you an IV to insert medicine because you're sick. Sometimes they give you an IV for pain medicine because you're in a lot of pain because maybe you've had surgery. So an IV is not always for the same thing, right? So it can change. Do you control the change?
No.
Your doctor controls the change, right? Right. But he controls what goes in your IV. Because is it the same for everybody? No. It's going to be different for everybody. But he controls it. Can he control how you feel? No. Can he control what's wrong with you?
No.
No. Can he control how you're going to feel afterwards?
Yes.
Yeah.
He can't control that. Otherwise, he'd just press a button. You're better. It would be awesome. But sometimes it takes multiple different medicines to figure out what is going to make you better, right? Right. So he can't control how you're going to feel afterwards, but he can control what? Eric.
Control, like how control like medicine and stuff.
He controls the medicine. He controls what goes in your IV. So the independent variable is like an IV of your science experiment. You control what you change. This is the one thing that you change in your experiment. Because you don't have 5 IVs sticking in your arm, do you?
I got 2.
You have 1 at a time. They may have little things.
No, like they had one in my hand, but then it started to hurt.
Right, so they took it out, they give you a new one.
Yeah.
Right, but you only have 1 at a time. Right. So, this is one thing that you can change, that you have control over in your experiment. So, for example, if my experiment was, does the temperature of a magnet affect how many paper clips it'll pick up? What is the one thing I'm changing in that experiment? Eric? The temperature. I can control the temperature of the magnet. Can I control how many magnets or how many paper clips Can I control how many paper clips it's going to pick up? No. We have to pause because we have to go to lunch. Control group or control variable. The control group is the norm. Okay? This is the normal thing. This is the thing or the items that always stay the same in your experiment. So if I'm doing does the temperature of a magnet affect how many paper clips it's going to pick up? What is staying the same each time I do that experiment? What am I not changing? Evelyn. The type of magnet. Now I'm changing the temperature, right? But I'm not changing the type or the size of the magnet because that can make a difference on how many paper clips it picks up. What else am I not changing? Aislinn.
How many times did you do it? The good number of times. So you don't
Right.
change it.
I'm not going to change the number of times I do it. What else am I not changing? Alex. Oh. Jenny. Oh, what?
What you're doing
What items in the experiment am I not changing, Alex? Like what? I need to know specifically, what am I not changing? What is staying the same every time? I know the magnet size and the magnet type is staying the same. What about my paper clips? Am I changing my paper clips? Am I going to use plastic coated paper clips one time and just plain metal ones the next? No, because I can only change one thing, and I'm changing the temperature of the magnet. So that means the magnet's size and brand is staying the same, and the paper clips are staying the same. The freezer that I use to make my magnet cold is staying the same.